Welcome all. Today we'll be discussing Azure Network Perimeter Defense with the great Leo. Thank you and thank you for joining. We've just got a couple of house call things before we get into the session. So this session is delivered on behalf of the Azure Cloud Commanders Learning Room. So it's a Microsoft Teams tenant community based from Microsoft Worldwide Learning that exists to really help you learn, get certified in Azure. It's completely free. There's sessions like this on different topics and different learning rooms as well. So my one's focused on Azure infrastructure, but there's people that have learning rooms for data and AI. So make sure you check out the aka.ms learning rooms link. My name is Luke Murray and I'm like a Microsoft MVP and Learn expert, and I'll be moderating the chat today. So if you have any questions during today's session, we'll try and do questions at the end, but Leo will be monitoring the chat throughout as well. But if you've got any questions, feel free to put it in the chat and we'll get to you. So this session has been recorded. If you do not consent to be part of the recorded session, please disconnect your line. As attendees, your name is hidden on the recording. However, if you do come off mute or have your camera on, your voice and video will be recorded along with anything that you may mention. So try not to mention company names and personal details, etc. The recording will be published on YouTube for later viewing for those that can't make it or need to drop off early, and the link will be posted in the learning room once it's available. Just some code of conduct. So it's an inclusive session, so be welcoming, respectful, friendly, and considerate. There may be people attending who are coming in fresh and may not have heard any of the content being delivered today. So everyone is welcome and all questions are welcome. Raise your hand if you want to ask a question or just ask in chat. If you have issues viewing something on the screen, on the lower left-hand side of the Teams share window, you should be able to see a plus and a minus symbol, allowing you to zoom in and out of the content being delivered as well. Yeah, and today we've got Leo. I'll get Leo to sort of introduce himself properly soon, but Microsoft MVP, and he's here to talk to us today about Azure Network Perimeter Defense. So welcome, Leo, and thank you for joining us today and discussing this really interesting and valuable subject with us. Over to you.
Thank you very much. So I'm going to start with sharing my slides. And then we can start. Let's see if this works. Okay, can everybody see the slides? And can they hear me properly? I see some thumbs up. Great. Okay, so welcome everybody to the talk, The Castle in the Cloud. I am Leo Visser from the Netherlands. You can find me on most socials by the handle Other SysOps. And I'm a Azure Networking MVP. I work at a company called OGD, and I'm there a cloud consultant and also a product owner for automation, AI, and the Power Platform. So I do a wide range of different things. And today I'm going to tell you a little bit about some history I had with networking, some things I've seen a lot in the field. And this kind of prompted me to make this talk. Like Luke said already, if there's any questions, just put them in the chat and we can look at them afterwards. And maybe if I see them and I'm like, I can answer this instantly, I'll do it. So today, I'm going to first talk a little bit about the cloud. Then we're going to dive into the past. We're going to go back to the present. And then we're going to talk a little bit more about some technical stuff like zero trust. And then we're going to build our castle and then we're going to guard our castle. So I'm not going to take too much credit for the slide game, by the way. This is just a slide deck I got from a certain conference, and I just removed their logos to make it work. So kudos for whoever made this. So the cloud. We all know the cloud as somebody else's computer. It's the joke we always make. But when we're talking about the cloud in more of um, a system development context where we develop different systems, there's something interesting going on. Depending on who you ask, they will either be like, try to lock down everything, but I don't know about you all, but when I started doing my first experiments in the cloud, I was like, oh, I can have a web application. I can have an app service in the cloud which hosts my website, and I can have a database in the cloud, and it's all easily hosted. And they could just talk to each other. There's like this endpoint, and I just point them to each other. I don't need any networking. I don't need anything at all. Awesome. So there's many people when using the cloud, they really just use some of the services in the clouds, and they're connected over the internet with each other, and that all works. And depending on your use case, it's okay, or maybe not so okay. If I talk with people from .NET companies, .com companies which are really developing very quickly, often they don't see that much of a problem with having it connected over the internet. But if I talk to traditional system engineers, they really don't understand this why this doesn't make all the alarm bells ring at once. So to understand their perspective, we have to go back a little bit to the past. And this is where our castle starts. Because when we are doing networking in the past, and when I'm talking about the past, I'm talking about earlier days, but I'm also still talking about today, but I'm mostly talking about like the on-premise situation. I tend to call on-premise legacy. There's reasons to still use on-premise for sure, but for a lot of companies, if they're still using a lot of on-premise resources, they're kind of living in the past and they're not keeping up with the rest of the um, yeah rest of the companies. So if we had our castle, it was our network. It was everything in our buildings was connected to each other, and we made sure nobody could get in. We built a very big wall around it to protect ourselves. We called this wall the firewall. So just to make sure nobody could get in or out, we had this wall around our network, the firewall. And it's nice. We just have everything connected with each other, and nobody can get in or out, and it works. But then, well, we do need some connections. But before we had the connections, we actually wanted to protect it even more, because also in our company grew, and maybe we didn't want all the participants to also see all the servers, be able to connect to all the servers. So what we did is we started creating VLANs, virtual LANs, which were segments in our castle, which were walled off again. So we made sure they couldn't connect to each other, at least easily. But then a problem started. There was, for example, a supplier, a software vendor, which was like, well, you're using our software and we would love to help you, but if you have a problem, we're not going to drive towards your building. go in, go through all the security checks, and then click one button in a program and go out again. We want to have some remote access so we could watch your screens or configure some of the stuff in the software. So we had to create some kind of supplier access. So we made this little bridge for them. And we made sure that only they could use it. We protected very well. And then people wanted to work from different places. Corona made this even better or worse, depending on how you look at it. But we had business people working in different countries for a while. And they had to get access to the network to look up stuff, or people being on sick leave, but still being able to do some work while being at home. So we created the VPN, the virtual private networks. And it's this dotted line you see. It's this tunnel under the moat, this escape tunnel somewhere in the castle. There's this hidden door. And if you want, you can get through it. Nobody really talks about it that much. IT tries to ignore it as much as possible, but it does exist and people use it. So we had a very strong castle, but there is some access. People could connect to it, but it was all still quite rigid and controlled. And then we get more to the present day and to the thing called hybrid networking, hybrid systems. So we got this whole cloud thing going on. And suddenly, this whole cloud thing had to be able to also talk to our servers on premise, had to connect with many of our different data sources. We wanted to start to use Power BI in the cloud and make sure that we could connect to our data warehouse. We wanted to make sure that we could create some automations, that our email was present everywhere, that we had like this web email and so on. So suddenly, this whole castle with this beautiful wall around it, which we took many hours to perfect, make sure that every rule in there was correctly made, no extra port was open, and so on. And now it was all connected to the internet. And everything was accessible from the internet because all these different tools, they need to connect to it. So this kind of brought us to the point that we had to think about network security, about securing our whole data landscape, our applications in a different way. We couldn't just lock down the network, make this big wall, because there was so much connectivity needed. The world gets more and more connected. Everything has to be connected with each other, especially now with the introduction of AI assistants. Everything has to be connected. And these AI systems, often they can't run on their own systems. They're running somewhere else. They take all the data they want. And yeah, we just can't rely purely on this network barrier anymore. It's just not working. So we started to think what's the most important principles we have? If we're talking about securing our network, securing our data, what is really securing it? If we're thinking about the security, when is something secure? So we came to the three principles of zero trust. And you've probably seen these before. Sometimes they're worded a little bit differently. But the first one, verify explicitly. It means that every time somebody tries to reach some data, you will verify it. Again, you will verify that they have access. Now, when people started explaining this to me the first time, I was like, sure, but I couldn't really get grips to it, what it actually meant. So eventually, I started thinking about my data landscape as a hotel for a moment. I've been traveling a lot for different conferences and I've been staying in a lot of hotels also. And I started kind of thinking about this data. It was my hotel room. A lot of the times, if I'm traveling in my hotel room, there's stuff lying there. I can't take all the different equipment with me if I'm just going out for beers with other people in the city. Sometimes I do, but sometimes there's stuff in my hotel room. There's a lot of people walking around in this hotel, and it changes all the time. And everybody needs to have access to some points. So, with this verify explicitly, it's that every time you're trying to reach some part of the hotel, which can have some kind of important data stuff or whatever, you will have to use your key. So the first time you get to this hotel, you get this key card or physical key or whatever. If you still know hotels which use physical keys, by the way, I would love to hear. Then I can, nah, never mind. So this key, every time I have to show it, it's not that the first time I've shown my key to my hotel door, that the next time I can just walk through. No, every time again, if I want to go in, I need to use this hotel key. Even if I just left it, I just closed the door behind me. I was like, oh, wait, I forgot something. Still, I need to verify again that I can go in. That's what the verify explicitly means. You will check every time. And then using the least privilege access. Again, it's something I've heard many a times. But what does it actually mean? So I started thinking about his hotel again. If I'm a guest in this hotel and I do my check-in, I get my key. This key only works for my room. At least it should. Technically, if the hotel, I believe, has more than 8,000 rooms, there's a possibility, depending on the system they use, that it can work on two doors. But that's something for DEFCON, not for here. So imagine that when you checked into your hotel, you would get a key which just works on all the doors. They're like, well, yeah, here's your key. Your room number is this and this. Have fun with it. You might not even notice. I think most people, they don't check if their key actually works on different doors. At least not on purpose. Maybe if they're drunk, they actually try it. This is also why sometimes drunk people actually find the security holes in hotels, because they actually do this stuff without doing it on purpose. British people in the Netherlands tend to do this a lot, I heard. So if I got this key with access to all the doors, it's really not that safe. So that's kind of the least privilege access. You will only give me the key, which really gives me access to whatever I need. And this sounds so easily, but I think if we can do a raise of hands, I don't know if it works, but let's see. How many of you have been to some customer or have been in a project where they were like, so you have to do a lot of different stuff on this project. We don't exactly know what you have to do. So you know what? Here's a global admin or an administrator account for the Active Directory. I think some of you might have been in this situation. Yeah, I see some hands raising already. So thank you. That's giving the key with all the access, or maybe for only one wing, but that's not what we want. We want to use the least privileged access. And then the last one, assume breach. I could also, again, bring this back to my hotel room. If I would really trust the hotel, I could just open my door and leave it open. Oh, sorry, just tapped the. So I could just um, open my door, leave it open. When I go out of my room, I could just leave my door open. It makes my life easier. I don't have to check my badge every time. But I don't know about you, but if I walk out my hotel room, my door closes behind me. If I'm sleeping in my hotel room, the lock is on the door, just to make sure that even people with room service, with elevated accounts, they can't get in unless they really, really try to. So that's the assumed breach. We assume that there's people inside this building which try to access your data when you don't want them to, or maybe you don't want them to access it at all. So if we want to make something really, really secure, we have to make sure that we always verify explicitly that we only give the people access to what they really need. And we need to keep thinking about our systems in the way that they are breached. Because if we think about this, we won't do the easy trusting that much. When we were creating the internet, we mostly forgot that last one, which is still haunting us to this day with all kinds of different protocols having trust issues, DNS. So that was some introduction about some concepts. Now let's start to build our castle in the cloud. We want to create this cloud environment. We want to create something in the cloud which we can use, which our applications can be hosted in, which an enterprise can use, and they feel safe in it. So one of the things we can start using to build this castle, it's private endpoints. So I was talking earlier about this app service I can have in Azure. I can have this database in Azure. And they are what we call software as a service or platform as a service, services, resources, whatever. They don't have infrastructure on the line which we see. We take these services because we don't have to configure that much about them. The vendor will make sure that it's configured in the right way, it's maintained, and so on. But often they also don't really have networking capabilities. Maybe on very, very high paying tiers, but at least in Azure, a lot of the resources, they have the possibility to use what we call a private endpoint. This means that instead of having a public endpoint, which is directly pointed towards the internet, I can create an endpoint which is connected to my virtual network, the network I have in my cloud environment. And this private endpoint allows me to connect these resources to my network, which then makes it a little bit more secure, at least a little bit more controllable. I can see the data going, I can control how it's going, and I could maybe add doors in between. I could maybe add locks in between to make sure it's more controlled. To go back to the hotel metaphor again. So let's see if this works. I'm going to try to show you a little bit about a private endpoint. I think many of you know how it looks, but I like to show some things in Azure also. So let's see if this works. So I believe you're now seeing the Azure portal. Is that correct? Yeah, I see some thumbs up. Great. So this Azure portal has a lot of stuff in it. But one of the important things is here I've got a key vault. And in this key vault, I can have certain secrets. So I believe, yeah, if I look here at the secrets, you actually see that I'm not even allowed to look at them because this key vault, it doesn't have public access. So I can't reach it from the internet. Now, there is one important thing. This checkbox still enabled. This checkbox is a very tricky checkbox because it allows all Microsoft trusted services to still bypass these rules. So they can still connect from it to it from the internet. So that's a warning. If you want to really block something from the internet, you might also want to check or make sure this checkbox isn't checked. Now, trust me that there are some secrets or keys in there, although we're not even going to look it up. What we do have is this private endpoint. This private endpoint we can see. And it's connected to a subnet. So I can look at the private endpoint. It has some properties, but nothing that much. One of the important things is the DNS configuration. I'm not going to go too much into the DNS. I've got different talks going all deep dive into DNS by itself. I can tell you one thing. If some of this stuff is not working, most of the times the problem is DNS because it's always DNS. So once you've set up this private connection, let's go back. This private endpoint, you can connect it to a subnet. And once it's connected to the subnet, devices in the subnet, they can find it through the private DNS. So we have a key vault, which is normally not connected to a network at all. I don't see any IP address here or whatever. But now when I go to a virtual machine, and this virtual machine is connected to the same subnet, so encrypted network / default, I can actually try if I can reach this key vault. So also just because I like to show it, I'm going to use the serial console in Azure. Because we always learn that we shouldn't open up like RDP ports or whatever. But for demo purposes, I might still want to connect to this machine. So if you enable analytics for boot analytics, I believe it's called, you can actually use this serial console. And you will normally get something else first, and then you can open the command prompt. It actually opened the command prompt already. And I think it even already opened PowerShell. So what I'm going to do now, yeah, the serial console is tricky. So I'm going to check this key vault. This key vault, it has a URL, keyvault.vault.azure.net. So I'm going to resolve the DNS name for keyvault.vault.azure.net. Normally, you would expect some kind of URL on the internet, but you will see that it actually returns me a 10.0.0. So that's a private range IP address. If we check the IP address of this machine, it's actually 10.0.0.5. So these machines are now in the same network. And this is done by this private connection, this private endpoint. So let's go back to the slides. This is always the hard part. It should now give me a prompt to resume. Yes, great. So another thing is if we have this network, we have this virtual network in the cloud. So it's a network in the cloud. There might be a problem. This problem is the 30th of September 2025. I've already booked my holiday. All this talk about hotels made me think about holidays again. And if I were you, I would also book a holiday around this period of dates, because this is the moment when Azure is going to what they call disable the default outbound access. Because at the moment, virtual networks in the cloud, they might behave a bit different as you would expect them to when they're in their default setting. If I make a network in the cloud, a virtual network in the cloud, and I connect a virtual machine to it and nothing else, then this virtual machine has internet access. But if I would create like a network in my home, I would buy a switch, uh, buy a network cable, put the network cable in the switch, put the network cable in my machine, maybe add another machine to it. They would have a network together, but no internet access. I would actually need to have a router, need to check with my ISP, make sure that it can connect to my router, and probably also do some net, or I can both give them an IP address if I really want to do some really old stuff. But in the cloud, it actually has internet access by itself. Sometimes this is because you gave it a public IP address. Because if you create a virtual machine, you can give a virtual machine a public IP address. But even if you don't give a virtual machine a public IP address, it only has a private IP address in this virtual network. It still has internet access. And this is because when Microsoft was setting up virtual networks in Azure, this was considered kind of making it a bit easier for people to understand and making it easier to work with. But it's kind of against what you would expect would happen. So on the 30th of September 2025, they're going to change this, and they're going to make sure that all these virtual networks don't have default internet access anymore, which is great, but which also means that a lot of stuff is going to break. Because how are your machines going to download their updates? How are they going to do a lot of different things? All stuff to keep in mind. Now, I'm not going to go too deep into how to remediate this. One of the ways is to look into a NOT gateway. But if you're using Azure Firewall and so on, there's also possibilities. But there is a way we can already prepare for this. Especially if you're creating some new environments, you might already want to make sure that you're keeping this in mind. Now, you could just design your whole systems in a way that you know it's not using the internet access, but it's always nice to know for sure. So let's go. I think it's time to go back to Azure again. Yeah, it says demo 2. Let's go back to Azure. And if I'm going to my encrypted network, it's the network we were connected to, you will see that my network has 2 subnets. Before explaining a little bit more, No, I need to demo something first. So just to make sure that we're actually really connected to the internet with this virtual machine, let's do a quick test. Let's copy this. With a dash in front. So for the people who don't really know PowerShell, what I just did is I just asked it to get www.google.com, and it gave me back a status code of 200, which means that the website was retrieved successfully. So this would be the same as going to a browser and just entering www.google.com. So in this machine, I can actually reach the internet. And we can check that this machine doesn't have a public IP address. It only has a private IP address, and there's no trickery in the network with NAT gateway or whatsoever. This is the default behavior. You can actually see it in the rules also. Because it says here, allow VNet inbound, that everything is allowed. So now let's go to the network adapter. And what I'm going to do is I'm going to change this network adapter to the other subnet. So I'm going to move this machine to the other subnet. This takes a little while because the virtual machine has to reboot to make network settings change. I still don't understand why Microsoft still always says that if anything network-based change, you have to reboot the machine, even if you do it on your local machine, but also in the cloud. Apparently, just doing some flush DNS and getting it again and stuff like this isn't enough. Now, what am I doing? We had this default subnet. The default subnet, it looks as you would a subnet to expect. It has an address space, a starting address. You see that there's no NAT gateway, there's no security groups, no route table, nothing fancy. Now I'm going to connect it to the private subnet. And this private subnet, it has this tick box enabled, which says enable private subnet, no default outbound access. So this is a setting which has been in Azure now for a while. And if you enable this checkbox, the subnet will behave in the way all subnets will behave after September 30th, 2025. You can also set this checkbox with your infrastructure as code language of choice. I believe all of them by now have this one in one way or another, if you at least use some of the common ones. You still see that there's still no NAT gateway, security groups, route table, or whatsoever. So this is the only difference. Now, if we go back to our virtual machine, and let's see if it's running again. So now you will actually see the whole shebang of the serial console. Let's have it connect. Yes, so I'm going to open the command prompt. I'm going to open the command prompt. And I pressed an enter too much, so we have to do this again. Okay, this was ICT. We're logging in. This takes a little moment, and then hello, yeah. Then we're opening PowerShell, and now I'm going to do the same command again with the dash in front, of course. It takes a second because it's trying to get the web page. And you see by the amount of time it's taking already, something is going wrong. This is because now it's retrying and retrying, and it says unable to connect to the remote server. This is because we now prevent the outbound access. So this is what you can do with this subnet checkbox. So keep it in mind. So the next thing is, again, we have these suppliers, we have people. If we're building all kinds of applications in the cloud, we probably also want people to actually be able to check out our applications, make sure that they can access them. We could just give them a public IP address, give them a public endpoint or whatever. But that might not be the best way to do it. There is something which is called an application gateway. And an application gateway for people from more traditional networking is a reverse proxy. And it allows for a lot of awesome stuff. It automatically has auto scaling in it, so it will make sure that it scales up and down based on the traffic, some redundancy. And you can do tricks like header rewriting, where if somebody does a request, you can make small changes in the request to make sure it works better with your backend, mutual authentication, and so on. It has, and people who've been working with Azure for a while, they might have a hate-love relationship with the application gateway because it's a very powerful tool. But in the past, if you deployed it and it was done deploying within the hour, you were the lucky one. Because a lot of the times deploying the application gateway took a long, long time. And every time you wanted to make a change, it took a long time to propagate this change. And if you, in the meantime, made another change, it was a gamble if both changes would be propagated, if the first or only the second one was propagated. So it often was hard to really make it work well. But now they have the application gateway version 2. This one deploys in 2 or 3 minutes. It's done deploying, which is awesome. And the changes are also quite quick. So if in the past you've been burned by application gateway, try it again. Might surprise you. Also, one very interesting thing about the application gateway is that it has a WAF, Web Application Firewall. In here, you can protect applications you have from a lot of common attacks. So it has a built-in web application firewall which protects you from a lot of common attacks, and you can just put this in front of any application and make this application safer. If somebody created some kind of web application and you're not completely sure if it, for example, has some vulnerabilities with SQL injection, you can put this web application firewall in front and it will catch a lot of the SQL injection attacks already and make sure your application is not hit by it. So these are kind of the building blocks we need to build our castle in the cloud. But then we also need to guard the castle in the cloud a bit more. So we have this nice castle with a lot of moving parts, a lot of data going everywhere, and everyone can move however they want. And it's nice, but maybe you want to control it a little bit more. So if you follow things like the Cloud Adoption Framework, the CAF, or other frameworks, they will often say to create a hub and spoke network, which means that different workloads, different parts of your environment, you put in the spokes and they all connect to the hub. And from the hub, connections go to different places again. This allows you to focus your security efforts mostly on this hub. If you go back to our hotel again and say we really want very big rooms, then we could create long corridors everywhere and so on, and have doors everywhere. It's hard to see them. And maybe somebody would start lockpicking and we don't see it. But if we make sure that all the doors for all the different suites are in the main lobby in view of the counter where security sits, then if somebody wants to break in, they have to do it in plain view of security because they first have to go through this door, assuming that they can't break in through the windows or whatever. So that's kind of what the hub and spoke allows you to do. That you can focus your security efforts more on this specific spot instead of having to spread them out more. Now, also, a pet peeve of mine is that if we're creating a network in the cloud, it's quite easy to make configuration mistakes. So I would always recommend to enable flow logs. Flow logs is actually logging on your networks. If you give your network a network security group, you can enable a flow log on it, and it will just log all the traffic going in and out. You can even use traffic analytics to churn through all this data and present it in nice dashboards and even a graphical visualization of your network with all the different data streams going to from the different subnets to different places. So if you have a proper hub and spoke network, this visualization should show you your hub and spoke network. And if there's data bypassing the hub, you will actually be able to see it in this visualization. So I would really recommend it. Now, not so long ago, Microsoft also introduced flow logs for subnets, I believe, itself of over virtual networks it is. So you can now even, without having a network security group on the virtual network, you can enable a flow log directly on the virtual network. And on the 30th of September, Microsoft loves the 30th of September, 2027, so still in the future, they will actually deprecate the flow logs on network security groups. So it is something to keep in mind that if you're setting up a new environment, maybe not use the flow log on network security groups anymore. Last thing is Sentinel is always interesting to look at. It gives you a lot of extra security tools you can use. And VTAP is something very interesting where you can mirror specific ports and have this traffic sent to a specific point. So you can mirror traffic from different places and have it sent to one place so you can analyze it. This used to be a feature in Azure, but it was removed. If for some reason you think you need it, go check out the Learn page, the Microsoft Learn page about VTAP, and you will find some kind of form over there. You can enter this form, and if enough people fill it out, then maybe something will happen with it. Maybe you figure that I might want something to happen with it. Another thing is VNet encryption. So when we're talking about this zero trust principle and assume breach, one of the things we can do to make sure that if somebody is actually inside our network and we don't want them to cause much harm, is to make sure that even if they're inside our network, they still can't see anything by encrypting the traffic going over the network. So even if they're snooping around and they're trying to look at the traffic, if it's encrypted, they can't look at it. Not all applications support encrypting between different applications and databases and so on in the same way. If we're using HTTP traffic, we can use HTTPS and it's quite safe. If we're using FTP, there's FTPS and SFTP. One is a lot safer than the other one. Please look up which one at this moment is winning. And there's many protocols, they have a version of the protocol with an S in it to claim that it's more safe. But there's also many applications which just don't support it, especially older applications. I've seen applications still use HTTP to connect with each other, not being able to incorporate HTTPS and so on. And the company is like, well, it's inside our network and it's only internal traffic, so it's not that much of a problem, right? If we want to use zero trust, it is a problem. So a thing you can do is enable VNet encryption. VNet encryption allows you to say this virtual network is just encrypted by default. And every time some traffic from a virtual machine enters this network, it will automatically be encrypted. And once it exits the network, it will be decrypted again. And Microsoft makes sure this all goes okay without any problems. On your virtual machines, you will see the traffic without any problem. It happens between the virtual machine and the network inside the virtual network card in Azure. So if somebody is snooping on that network, they just see gibberish going, but you will have all your data with an extra layer of protection. Even if all your traffic is encrypted by HTTPS or whatever, you could still use it, because if your certificates are compromised, they could be snooping on the data. But if you also have this encryption over it, even if your certificates are compromised, they still can't access it, because they would need to break the double encryption. To break the double encryption, you need to break both of them. If you only have one, you have nothing. It's the Swiss cheese model for the people who know it. Just just put enough layers of Swiss cheese on top of each other, and eventually there will be no hole going all the way through. So, due to the time, I'm going to skip this demo. This demo is normally only showing how you can enable virtual network encryption. I've seen that Luke is posting a lot of links in the chat already. So if you follow these links, you will be able to just find where it is. It's one checkbox in your virtual network. You can enable it and it's done. So the last part of our castle, it's our hub. It's the hub. And what things can we use in this hub to protect it even more? If we have a simple network, we could use stuff like network security groups and application security groups. They are what we used to say layer 2 firewalls, access control lists. You can say, I have a specific IP range with specific ports and another different IP range, and traffic is only allowed to go between these IP ranges over these protocols and ports. For a lot of situations, network security groups in combination with maybe application security groups is enough. Application security groups is a way to make your network security groups a bit more manageable. You can create collections of rules and apply them to the different network security groups to make it a bit easier to manage. If you have a more advanced environment, a more complex environment, you might want to consider using an Azure Firewall. When I started out doing some network designs, the cheapest Azure Firewall was well in the thousands of euros per month. So convincing a small company to start using an Azure Firewall was quite of a challenge because making security cost so much was a challenge. Nowadays, there's the basic SKU for the Azure Firewall, which is a lot cheaper. It has not all the functions. I believe, for example, URL filtering is not in the basic SKU, and it has a lot less throughput, but it's also a lot cheaper. And for many companies, it's more than good enough. For bigger enterprises, the Azure Firewall is a very interesting tool. It has lots and lots of features. It has auto scaling, it's high available, it's so redundant. It won't go down unless the whole of Azure goes down. By the time your Azure Firewall goes down, other stuff has gone down already, and you will have other problems to think about then. Hey, my firewall now just went down. Your alarm bells are all going off already. So you can put this Azure Firewall inside your hub. There's pretty good documentation about how to set this up in the Cloud Adoption Framework and so on. You can make sure all the traffic will go through this Azure Firewall and centralize your management about the rules and so on to make sure this is all managed and secured and you've got grips on your network and your traffic. So to recap, if we want to create a safe environment in the cloud, we still have our beautiful castle. We have our castle in the cloud, but we need to stop thinking about the castle in terms of just a network and we're going to protect the network. We have to think about it with the zero trust principles. And this also means that we have to think about it more in the ways of identity. We have to start thinking about using the identities, the verify explicitly. Every time you have to show your key. If a machine wants to access another machine, it has to verify that it's this machine, either with certificates or with an identity or whatsoever, not just by an IP address or something network related. Because especially if things are connected over the internet, this becomes harder and harder. Using platform as a service services is nice because often they are more environmental friendly and they're often also a bit more cheaper. But a lot of enterprises, which I've seen, they shy away from them because it feels less secure. They know how to manage a virtual machine. They've been managing virtual machines for many years, but they don't know how to manage an Azure app service. So convince them to start using it. With stuff like private endpoints, it's very easy to do. And don't forget to monitor your systems. Don't forget the assume breach. You want to keep monitoring and keep checking to see if you can find these people who are inside your network and monitor to see if things are going wrong, if there's some misconfigurations. That was my talk. Thank you very much. You can find my blog, www.autosysops.com. I've had many write-ups about this subject already, going into more depths on different subjects. You can find me on the socials. Always feel free to reach out if you have questions, discussion topics, or interesting things you want to share. And if there's any questions, feel free to ask them.
we'll give a couple of minutes for questions, but thank you, Leo, for coming and giving up your evening to discuss this with us. The chat off to the side has been quite rolling, which is really good to see that participation happening and people sharing their own examples and questions. So thank you very much. If you, for the attendees, if you do have any questions, feel free to raise your hand or put it in the chat. But we'll end the recording now. Thank you.
Let's see if the recording actually stops.